Look down. No further. Past the concrete and the soil, past the shallow graves of forgotten towns and the tangled roots of ancient trees. Look past the bone and the fossil, past the compressed remains of seas that dried 100 million years before the first human concept of 100 million years. Look down into the planetary memory, into the rock itself. What do you see there? You see layers. You see pressure and time. You see a story written in a language of stone, a story of incredible violence and serene, patient stillness. It is the only true history of this world. And we believe, with a certainty that feels as solid as the ground beneath our feet, that the final chapter of that book is about us. We are the climax. We are the purpose toward which all those eons of silent, grinding geology were aiming. After 4.5 billion years of quiet contemplation, the Earth finally produced a voice. Our voice. But what if that isn't true? What if we are not the first time this planet has spoken? What if the story of civilization on Earth is not a monologue, but a dialogue, and we have simply arrived too late to hear the other voice? What if buried deep in the grammar of the stone, there are whispers of another mind, another city, another global empire that rose, flourished, and vanished so completely that its memory exists only as a subtle anomaly in a layer of ancient mud? This is not a question about aliens from other stars. This is a question about ghosts. Ghosts of the Earth itself. The silence you hear when you ask this question is the silence of deep time. It is vast and terrifying, and it holds secrets we have not yet learned how to ask for. We have looked to the stars for signs of intelligence, for a reflection of ourselves in the cosmic dark. But perhaps we should have been looking down all along. Perhaps the greatest alien of all is not out there. Perhaps it is right here, sleeping under our feet. There is a lie we tell ourselves, a comforting and necessary illusion that makes the day possible. The lie is that the world is solid, is stable, that the things we build are permanent, that the story we write upon the surface of the Earth will endure. We see our cities of glass and steel as monuments, as final statements. We see our history as a continuous, unbroken line leading from the primordial soup directly and inevitably to us. This is the foundational myth of a technological species. It is the ego of civilization. But the Earth does not care for our ego. The planet is a machine for erasure. It is a library where the librarian is constantly burning the books. Plate tectonics, erosion, sedimentation, subduction. These are not just geological terms. They're the instruments of a planetary amnesia. The surface of the Earth is a temporary canvas, constantly being scraped clean, ground down, melted, and reformed. Less than 2% of the Earth's current surface is older than 2.5 billion years. Most of the ground you have ever walked on is a geological infant, a fresh slate. Anything that happened on the 98% of the planet that has been recycled is gone. Not just buried, gone. Melted back into the mantle, its atoms reassigned to new minerals, its history erased at a fundamental level. So when we ask, are we the first? We are asking a question of a witness who has a very, very bad memory. We are looking for a single sentence in a library of trillions of books, all of which have had most of their pages torn out. This is the first layer of truth that begins to dissolve our comfortable certainty. The ground is not solid. It is a churning, chaotic sea of rock moving on a timescale, so immense it appears still to our fleeting lives. The history we stand upon is not a foundation, it is a raft. For most of our history, this didn't matter. We were a local phenomenon, a clever ape with fire and sharpened sticks. But then, something changed. We began to speak to the stars. In 1961, a young astronomer named Frank Drake did something remarkable. He tried to give a number to our loneliness. He gathered a small group of the world's finest minds at Green Bank Observatory, a place of listening, and he proposed an equation. It was not a physical law in the way of gravity or thermodynamics. It was an exercise in organized curiosity, a way to structure our ignorance. The Drake equation. It has become a modern icon, a string of variables that represents our deepest cosmic question. Are we alone? It begins simply enough. The rate of star formation, the fraction of those stars with planets, the number of those planets that could support life. These numbers, we are beginning to learn, are large. The universe, it seems, is generous with its potential homes. The ingredients for life, water, carbon, organic molecules, are scattered like dust throughout the cosmos. Nature, it appears, is not stingy. It sets the table for life everywhere. But then the equation turns inward. It becomes a mirror. What fraction of those life-bearing planets actually develop life? We have only one example, our own. One data point is not a trend. It is a single, unrepeatable miracle or a statistical inevitability. We do not know which. Is the leap from non-life to life a near certainty given the right conditions, or is it a cosmic lottery win of such staggering improbability that it has happened only once here? We don't know. The equation stares back at us, silent. Then, what fraction of life becomes intelligent? Look at our own world. Life has existed for nearly 4 billion years. Of the billions of species that have ever lived, only one has developed what we call technology. Only one has learned to write equations about the stars. This suggests the odds might be punishingly low. Intelligence, at least our kind of intelligence, may not be a goal of evolution. It might be a bizarre and beautiful accident, a fluke. Again, the equation is silent. One data point, us. And then the final, most terrifying variable, L, the length of time that a technological civilization is detectable. The lifespan of a species that has learned to speak, but has not yet learned what to say. This is the variable that haunts us. This is the great filter. All the optimistic numbers in the first part of the equation, the billions of stars, the trillions of planets, can be reduced to a heartbreaking zero by this one factor. If the lifespan of a technological civilization is short, if they inevitably destroy themselves, or exhaust their resources, or are snuffed out by a random cosmic event, then the galaxy could be a graveyard of forgotten lights. A vast, silent ruin of civilizations that lasted for a few thousand years, a mere blink in the cosmic eye, before vanishing forever. When we try to estimate L, we have no data points. Not even one. We're living our data point right now. We do not know if we will last another 100 years or another 100,000. We are a question mark at the end of our own equation. For decades, this was the framework. We looked out. We strained our ears for a signal from the void, for a brother, a sister, a distant cousin in the family of mind. We assumed that if there were others, they were out there. The search for extraterrestrial intelligence was, by its very nature, a search for others, elsewhere. But in the year 2017, a simple, profound, and deeply unsettling question was asked. It was a question that flipped the entire equation on its head. It did not come from a wild-eyed mystic, but from two deeply serious scientists. Adam Frank, an astrophysicist at the University of Rochester, and Gavin Schmidt, the director of the NASA Goddard Institute for Space Studies. They were not looking at the stars. They were looking at climate change. They were studying the geological footprint of humanity, the layer of evidence we are currently laying down in the rock. The Anthropocene. They were trying to understand what our civilization would look like to a geologist 100 million years from now. And as they did, a strange thought began to form. A thought experiment. A ghost story told in the language of geochemistry. What if we have done this before? Not us, not humanity, but something else. A terrestrial intelligence. An earlier chapter. They gave this thought experiment a name that lent it a certain pulp fiction charm, a wink to a classic science fiction television show. They called it the Silurian hypothesis. The name comes from the Silurians, a fictional race of intelligent reptiles from Doctor Who were said to have existed in Earth's deep past. The name is whimsical. The question is not. The question is this. If an industrial civilization existed on Earth millions of years ago, what traces would it have left behind? And would we be able to see them? This is the birth of the idea as a formal scientific query. It shifts the entire axis of the search. It suggests that the variable L in the Drake equation, the lifetime of a civilization, is not just about the future. It is about the past. And it suggests that the number of technological civilizations in the galaxy might not be the only question. Perhaps we should also be asking, what is the number of technological civilizations per planet? Is that number always one? Or could it be more? The first instinctive response to this idea is to dismiss it. It sounds like fantasy. Surely we would know. Surely there would be ruins, a fossilized skyscraper, a petrified machine, the wreckage of a forgotten metropolis half buried in a canyon wall. We are creatures of the macro world. We think in terms of objects, of things we can hold and see. Our archaeology is a search for artifacts. A botschaft, an arrowhead, a tomb. But the Siluria hypothesis is not about archaeology. It is about geology. And the timescales of geology mock the permanence of objects. Consider our own world. What if our civilization will survive in 65 million years, the same amount of time that separates us from the last of the dinosaurs? Every city, every road, every monument will be gone, ground to dust by wind and water, swallowed by the earth, melted in the furnaces of the mantle. The sheer, relentless churning of the planet's surface will erase every single structure we have ever built. The Great Wall of China, the pyramids of Giza, the concrete canyons of New York City, they're all ephemeral, transient scribbles on a page that is destined to be pulped. The chance of finding a fossil of a human, let alone a fossil of a human artifact, is vanishingly small. Fossilization is an incredibly rare event. It requires specific conditions, rapid burial in sediment, an absence of oxygen, a lucky geological journey through the ages. Most living things simply decay and disappear, their atoms recycled back into the biosphere. The fossil record is not a complete encyclopedia of past life. It is a handful of blurry, torn-out pages. We know of the dinosaurs primarily because they were so numerous, so large, and existed for such an incredibly long time. Their sheer biomass and temporal persistence increased the odds of a few of them winning the fossil lottery. An industrial civilization, even one that lasts for 10,000 or 100,000 years, is a geological eye blink, a flash in the pan. Its physical footprint, its cities and machines, would be a thin, temporary veneer on the surface of one continent. Geologically, it would be almost invisible. The odds of one of its artifacts fossilizing and then being conveniently exposed for us to find millions of years later are statistically indistinguishable from zero. So, searching for a fossilized factory is a fool's errand. It is looking for the wrong kind of evidence. It is like listening for a whisper in a hurricane. This is the core problem the hypothesis presents. It forces us to abandon our intuitive, object-based thinking and to start thinking like a planet. To understand what a civilization truly is, not from the perspective of an inhabitant, but from the perspective of the rock itself. What does a planet remember? It does not remember steel or plastic or poems. It remembers chemistry. It remembers energy. It remembers sudden, global change. A civilization, from a geological perspective, is not a collection of things. It is a process. It is a sudden, localized reversal of entropy. It is a species that learns to cheat the natural energy budget of the planet. For billions of years, life on Earth ran on a simple energy source, the sun. Photosynthesis captured solar energy and stored it in organic matter. This was a slow, steady, sustainable economy. But an industrial civilization does something different. It finds the planet's savings account, the fossil fuels, the buried sunlight of hundreds of millions of years, and it begins to spend it all at once. This act of planetary arson is the signature. This is the evidence that might survive the deep ravages of time. So let us dive deep. Let us become planetary detectives, sifting through the layers of time for clues of a crime that may have never happened. What are the rules of this unseen world? What is the taxonomy of its strange evidence? The first clue we must look for is in the air itself, or rather, the memory of the air trapped in ancient sediments. When we burn fossil fuels, coal, oil, natural gas, We are releasing vast quantities of carbon that were once part of living organisms. This ancient carbon has a specific chemical fingerprint. Carbon comes in different flavors, different isotopes. The most common is carbon-12. A slightly heavier, rarer version is carbon-13. Living things, through the process of photosynthesis, have a slight preference for the lighter carbon-12. They are picky eaters. So, when you analyze the carbon in a living tree or a plankton, you find it is slightly enriched in carbon-12 compared to the carbon in the atmosphere or the oceans. Fossil fuels are the compressed remains of ancient life. They are hundreds of millions of years of this biological preference, concentrated and buried. When you burn them, you release a massive plume of carbon-12 rich carbon dioxide into the atmosphere. You are changing the isotopic ratio of the entire planet's carbon cycle. You are, in effect, making the atmosphere look more alive in its chemical signature. This sudden spike in light carbon is a geological scream. It is unnatural. It is a clear signal that someone has been burning the planetary furniture. This isotopic anomaly gets recorded in the shells of marine organisms, in limestone formations, in any sediment that captures a snapshot of the atmosphere at that time. We're doing this right now. The carbon we're pumping into the air has a distinct isotopic fingerprint, a calling card of the Anthropocene. A geologist 100 million years from now, analyzing a core sample from our time, would see a sudden, sharp, and inexplicable shift in the carbon isotope ratio. They would know something very strange happened. They would call it the Seuss effect. They might not know it was us, but they would know it was something that defied the normal rhythms of the planet. So, the first question for the Silurian hypothesis is, do we see any other event like this in the geological record? Are there other sharp, negative carbon isotope excursions that are not easily explained by known natural phenomena, like volcanism or asteroid impacts? The answer is maybe. There are several such events in the Earth's history. The most famous is the Paleocene thermal maximum, or PTM, which occurred around 56 million years ago. During the PTM, global temperatures soared, the oceans acidified, and there was a mass extinction event. And right at its heart is a massive, negative carbon isotope excursion, very similar in character, though perhaps slower to what we are causing today. The conventional explanation for the PTM is a massive release of methane from undersea clathrates or huge volcanic eruptions. These are natural causes, but the event is still not fully understood. It is a puzzle. The Silurian hypothesis offers a different, more provocative lens through which to view this puzzle. It asks us to consider it, just for a moment, as a possible technosignature, the echo of a forgotten industrial age. The second category of evidence is more tangible, yet more insidious. Our garbage, specifically our plastics. We have created a class of molecules that the biosphere has never seen before, and for which it has no appetite. Complex, long-chain polymers that are incredibly durable. They do not biodegrade in any meaningful human timescale. They break down, yes. They are weathered by sun and surf into smaller and smaller pieces, microplastics, nanoplastics. These particles are now found in every corner of the globe, from the deepest ocean trenches to the highest mountain peaks. They are entering the food chain. They are being incorporated into sedimentary layers. We are creating a new type of rock, a plastiglomerate, where natural debris is cemented together by melted plastic. We are creating technofossils. What would these look like in 100 million years? The plastic itself would likely not survive. The complex organic molecules would eventually break down, but they might leave behind a chemical ghost. A layer of sediment unusually rich in strange, complex hydrocarbons, molecules that look nothing like the simple lipids and proteins of natural biological decay. It would be a chemical anomaly, a layer of molecular weirdness that would puzzle future geochemists. Are there such layers in the Earth's past? Have we ever looked for them? The answer is no, because we never had a reason to. We did not know what to look for. The search for these specific, unnatural molecules has never been a priority in paleontology or geology. We are blind to the evidence because we have not yet conceived of the crime. The third signature is written in the soil itself. Modern agriculture is a miracle of chemistry. To feed 8 billion people, we have had to bypass the natural nitrogen cycle. We pull nitrogen gas directly from the atmosphere using the Haber-Bosch process, an energy-intensive industrial reaction, and turn it into fertilizer. We are now producing more reactive nitrogen than all of the planet's natural terrestrial processes combined. This flood of artificial fertilizer runs off our fields and into our rivers and oceans. It creates vast dead zones, oxygen-starved regions where marine life cannot survive. This anoxia, this lack of oxygen, changes the chemistry of the seafloor, creating distinct layers of black, organic-rich shale. A geologist of the future would see a sudden, global spike in these anoxic ocean events. They would also see a shift in the isotopic signature of the nitrogen recorded in the sediments, a clear sign that the planet's nitrogen cycle had been hijacked by some powerful new process. So we ask the rock again, has this happened before? Are there other periods of widespread ocean anoxia that coincide with other strange signals, like a carbon isotope anomaly? Yes, the PTM, again, shows evidence of widespread ocean anoxia. So do other mass extinction events, the so-called oceanic anoxic events of the Cretaceous period. The conventional explanations are natural, changes in ocean circulation, climate warming. But again, the Silurian hypothesis whispers in our ear, asking us to look at the evidence from a slightly different angle. The final and most dramatic piece of evidence is the shadow of extinction. An industrial civilization, through its activity, its pollution, its transformation of the landscape, inevitably puts immense pressure on the biosphere. It triggers a mass extinction event. We're doing this now. We are living through the 6th mass extinction in Earth's history. Species are vanishing at a rate 100 to 1,000 times the natural background rate. This loss of biodiversity will be starkly visible in the fossil record. Future paleontologists will see a dramatic winnowing of life, a sudden quietus in the long song of evolution. So, the question becomes, do other mass extinctions in the past show the other telltale techno-signatures? A carbon spike? A nitrogen anomaly? A strange chemical residue? A layer of unusual sediment from widespread soil erosion caused by deforestation and agriculture. This is the method of the planetary detective. You're not looking for one clue. You're looking for a conspiracy of clues, a collection of independent, anomalous signals that all point to the same unbelievable conclusion. You're looking for a convergence of evidence, for shadows on the wall that, when seen together, create the outline of a ghost. This is the deep dive into the science of the unseen. It requires us to learn a new language, the language of isotopes and sedimentation rates, of anoxic events and molecular fossils. It requires us to accept that the most profound evidence of intelligence might not be a monument, but a subtle change in the planet's metabolism. And this is where the paradox begins to amplify. This is where the story turns back on us. Because as we assemble this checklist of potential techno-signatures from a hypothetical past civilization, we realize we are writing a perfect description of our own geological footprint. We are the ghost. The carbon isotope excursion, that is our fossil fuel emissions. The strange chemical layer, that is our plastic pollution, our persistent organic pollutants, our synthetic steroids that will leave bizarre molecular fossils. The nitrogen cycle anomaly and oceanic anoxia, that is our industrial agriculture. The mass extinction event, that is our legacy, the great silence we are leaving in the biosphere. The Silurian hypothesis holds up a mirror. It forces us to see ourselves not from our own fleeting human perspective, but from the perspective of deep time. It recontextualizes our entire civilization. We are not building a permanent home. We are creating a geological anomaly. We are a brief, feverish, and incredibly powerful event in the life of the planet. This is perhaps the most unsettling realization of all. The reason we can even conceive of the Silurian hypothesis, the reason we know what to look for, is because we are currently providing the perfect template. We are the control case. The very act of looking for a past civilization is made possible only by the fact that we ourselves are becoming the kind of civilization that might one day need to be found. This violates our sense of ourselves. We are the protagonists of our own story. We think of our impact on the planet as a new thing, a modern problem. But what if it is an ancient pattern? What if the trajectory of any species that crosses the threshold into industrial technology is tragically predictable? What if the arc of a technological civilization is always the same? Discovery, expansion, consumption, and collapse, leaving behind a thin, messy scar in the rock as its only epitaph. This introduces the role of the observer in a new and profound way. Our consciousness, our scientific knowledge, is what allows us to formulate the question. But our actions are what provide the clues. We are both the detective and the perpetrator of the very crime we are investigating. This leads us to the core philosophical abyss that the hypothesis opens up. It is a journey that takes us from particles of rock to the nature of personhood itself. If a civilization can exist, can build, can think, can dream, and then vanish so completely that its existence is debatable, a mere statistical phantom in the geological noise, then what does it mean to be real? We define our reality through our works, our memory, our history. We point to our libraries and our cities and our art and say, this is us. This is real, but the planet tells a different story. The planet suggests that all of this is transient. All of it is destined for erasure. From the perspective of the Earth, a civilization is less like a mountain and more like a weather pattern. A brief, turbulent storm that passes, leaving behind only subtle changes in the landscape. So what are you? You are a collection of atoms, borrowed from the planet. You are a standing wave of consciousness in a universe of vibrating fields. You are built from the dust of long-dead stars. This is the poetry of cosmology. But the Silurian hypothesis adds a new, more unsettling verse. You are also built from the ghosts of your own world. The carbon atoms in your body have been part of countless organisms before you. They have been rock, they have been air, they have been water. And if the hypothesis is true, some of them may have been part of another thinking being, another mind that looked at the stars from this same planet 60 million years ago. You are a collection of memories, but those memories only go back a few decades. The vessel that holds you, this body, is part of a chain of information, DNA, that goes back billions of years. But what if the planet itself holds a different kind of memory? A memory of mind itself. This is the leap into speculation, the point where the science becomes a launch pad for deeper, more profound questions. Could it be that intelligence, consciousness, is a recurring phenomenon on a suitable planet? An emergent property that flashes into existence when conditions are right, persists for a while, and then fades. Is civilization a stable state, or is it an unstable excitation? A brief, bright resonance that cannot sustain itself. This redefines reality. It suggests that our common-sense perception of a solid, historical, linear progression is a profound illusion, a trick of our short lifespans. The true reality is a cyclical one, a story of emergence and collapse, of quiet eons punctuated by brief, feverish moments of technological intensity. It forces us to ask what we even means. Is we just Homo sapiens? Or is we the planet's capacity for thought? Are we simply the current vessel for a potential that has always been here, latent in the chemistry and complexity of the biosphere? Are we the first expression of that potential, or just the latest? This is the ultimate deconstruction of our anthropocentric worldview. It disenters humanity not just from the cosmos, but from the history of our own planet. It suggests we are not the owners of this world, but merely its current tenants. And we may not even be the first tenants to have thrown a very destructive party. So, we return to the central question, the one we started with. But now it sounds different. Are we the first? Perhaps the answer is not a simple yes or no. Perhaps the question itself is flawed. It assumes a linear race with a starting line and a finish line. But what if there is no race? What if there is only a cycle? A planetary heartbeat, with long periods of systolic quiet and brief, intense bursts of diastolic complexity. To ask, are we first, is to imply a competition. But maybe we are not in competition with anyone. Maybe we are just another iteration of a natural planetary process. The true gift of the Silurian hypothesis is not the answer it might provide. We may never find definitive proof of a past civilization. The evidence may be too faint, too ambiguous, lost forever to the grinding of the geological machine. The ghost may remain a ghost. The true gift is the question itself, is the profound shift in perspective it demands. It asks us to see our world not as a stage built for us, but as an ancient, living entity with a history so deep it is almost beyond our comprehension. It asks us to feel the immensity of time beneath our feet, to understand the terrifying fragility of our present moment. It connects us, not to aliens from the stars, but to the very rock and water and air of our own world. It dissolves the barrier between our civilization and the planet, showing us that they are not separate things. Our civilization is a geological event. Our thoughts, our actions, our pollution, they're all being written into the stone. We are actively composing the message that we will leave for the deep future. What should that message be? The final metaphor, then, is not one of ghosts or of crimes. It is one of writing. The Earth is a book, an epic poem written over 4.5 billion years. Most of its pages are lost. Its language is hard to read. Life itself is a form of poetry written in the alphabet of DNA. A technological civilization is a chance to write a new verse in that poem. A verse of self-awareness. A verse of mathematics and art and music. A verse about the universe understanding itself. The Silurian hypothesis is a warning that this kind of verse might be very short. It might be a brief, frantic, and self-destructive scrawl, quickly erased by the next turn of the page. Or it could be something else. This is the final thought, the parting reflection that this journey through deep time leaves with us. The knowledge of our own potential transience is not a cause for despair. It is a call to responsibility. It is a challenge. Knowing that our footprint is both immense and ephemeral, that we are simultaneously powerful enough to change the planet and fragile enough to be erased from its memory, gives us a new sense of purpose. It encourages us to be better ancestors, to think not just about the next election cycle or the next fiscal quarter, but about the signal we are sending down through the millennia, to think about the quality of the verse we are writing. Are we writing a verse of short-sighted consumption and collapse, a messy, ugly scar in the rock? Or are we writing a verse of wisdom, of sustainability, of a species that finally understood its place not at the pinnacle of creation, but as a humble and fleeting part of a much grander, much older story? The ghost of a possible past civilization does not haunt us with its presence. It haunts us with its choices. It asks us, across the gulf of unimaginable time, will you make the same mistakes we did? You are standing on a planet that may have forgotten more than you will ever know. You are a brief flicker of awareness in an ocean of time. You are a child of this earth, and like all children, you have the choice to learn from the stories of your elders, even when those stories are silent, written only as a whisper in the heart of the stone. Look down. The ground beneath you is not just rock. It is a warning. It is a question. And your life, your choices, our civilization, they are the answer.